Let's look at this graphic. Route 1 is the gateway to LAN 1 with 25 hosts. Route 2 is the gateway to LAN 2 with 55 hosts. And Route 3 is the gateway to LAN 3 with 12 hosts. 3 routers are connected to each other. Here is the question. The network consists of 3 local area networks, LAN 1, LAN 2, and LAN 3. These 3 LANs are connected with 3 serial links, link A, link B, and link C, with an ID range 192.168.4.0/24. Please design an IP plan for the network using Vlsm. In this network, we have 6 networks, LAN 1, LAN 2, LAN 3, link A, link B, and link C. Links A, B, C are also 3 separate networks, and each needs 2 host IDs. Thus, our task is to design an IP plan for each of these 6 networks, depending on their sizes. Thus, we use Vlsm subnetting method. We need 5 steps to solve the problem. Step 1. Arrange the networks from the largest to the smallest. Thus, the largest one, LAN 2 with 55 hosts. The next largest one, LAN 1 with 25 hosts. The third largest one, LAN 3 with 12 hosts. And the fourth largest one, or the smallest one, links A, B, and C. These 3 networks can be arranged together because they are of the same size. Each subnet needs 2 host IDs. Once they are in a descending order, we need next 4 more steps to complete our task. Step 2. Pick a subnet for the largest network to use. We start with LAN 2 with 55 hosts. Let's look at the second row in the table. We are looking for the minimum number of hosts which can satisfy LAN 2. That's right, 64 is what we need. We circle 64 and the whole column because all we need are these 3 numbers in this column. 4, 64/26. 4 means 4 subnets. 64 means each subnet has a total number of host IDs. 64/26 is a new CIDR value. Now we will use these 3 numbers to build a new table with network ID, subnet mask insider value, host, the network. Let's fill in the columns of subnet mask and host first with /26 and 64. And these 2 numbers are directly from the column. In the host column, 64 is the total number of host IDs. Keep in mind, the first host ID is reserved for the network ID and the last host ID is reserved for the broadcast ID. The total number of usable host IDs for each subnet is 62. Now let's list a network ID for each subnet. The first network ID is always the original given ID, which is 192.168.4.0. The second network ID is 192.168.4.64. The first three octets remain the same, and only the fourth octet changes. Thus, we only focus on the fourth octet. The third network ID is .128. The fourth network ID is .192. Here is the pattern. The first network ID is always the original one. The next network ID is obtained by adding 64 to its previous one. We can assign any of these four subnets to line 2 because they are all equal size. For the sake of simplicity, we assign first subnet to line 2. The other three subnets are marked unused at this point, and they are for future use. We have completed the task to design an IP plan for the largest network, line 2, and move to the next step. Find a subnet for line 1 with 25 hosts. Step 3. Pick the next largest network to work with. Step 3 repeats the process of Step 2. First, look at the second row in the Sunny table. We are looking for the minimum number of hosts, which can satisfy line 1 with 25 hosts. That's right. 32 is what we need. We circle 32 and the whole column because all we need is this column. Let's look at the second table. We select first unused subnet and subdivide it into two smaller subnets. The new subnet mask is /27 insider, and the total number of host IDs is 32, which can satisfy line 1, which only needs 25 host IDs. Dividing one subnet into smaller subnets is called subnetting a subnet. Let's choose 192.168.4.64/27 for line 1, and we mark the second one, 192.168.4.96/27, unused at this point, reserved for the future use. We have completed the second largest network, line 1, and we move to the next step. Find the subnet for line 3 with 12 hosts. This step repeats the process above. Let's look at the second row in the Sunny table. We are looking for the minimum number of hosts which can satisfy line 3 with 12 hosts. 16 is the number. We circle 16 and the whole column. Now we want to subnet the unused network 192.168.4.96/27 and further divide it into two smaller subnets with a new subnet mask /28 with 16 total host IDs. We choose 192.168.4.96/28 for line 3, and we mark 192.168.4.112/28 unused at this point and reserved for the future use. We have completed step 4 and we move to the last step. We want to assign 3 smaller subnets for serial links A, B, and C. Each link needs 2 host IDs. Step 5 is last step because once we get subnets for these 3 links, we are done. Let's look at the second row in the table. we are looking for the minimum number of hosts that can satisfy a network with only 2 hosts. We believe the number 4 is what we are looking for. We circle 4 and the whole column. We can see the new subnet mask is /30. We choose the unused subnet 192.168.4.112/28 to further divide it into 4 smaller subnets. Why 4 smaller subnets? I leave this question to you. Now let's fill out these 4 new rows. We only focus on the 4th octet instead of reading the whole IP addresses. I believe you are already tired of my accent. The first one is .112/30. The second one is .116/30. Third one is 120/30. The fourth one, 124/30. Each subnet has 4 host IDs, which are exactly what we need. The first ID is reserved for the network ID. The last one is reserved for broadcast ID, and 2 usable IDs are assigned to 2 routers on each link. We can assign any 3 out of 4 subnets to links A, B, and C. For the sake of simplicity, we assigned the first 3. The fourth one is marked unused. We have completed the last step, and we are done